Okay, this is for honors physics, test review question 5. Several people have asked for this. This is like the racing dragonflies on the practice test, and so these problems are a little bit difficult to set up, but now that you've seen it 2 or 3 times, you should be able to solve it if it comes up Friday on the test. So we have a first car, we'll call that car number 1, starts from rest. So initial velocity equals 0 and has uniform acceleration. The second car starts from rest 6 seconds later. So the first car is going to have a 6-second head start. The second car accelerates uniformly but faster. Okay, also from rest. V0 equals 0. How long does it take the second car to overtake the first car? So they have overtaken or passed when the displacements are the same. The second one has caught up. Okay, and since we have v0 equals 0 for both cases, our famous equation 2 becomes just delta x, or x minus x0 equals 1/2 at squared. Okay, so this problem's a little bit hard to set up because one car has a 6-second head start, but because the initial velocities are 0, it's manageable, and as you can see, there's kind of a shortcut to solve it. So there's my setup. We'll just kind of make a chart. We'll make an equation. We're going to say the first car is t plus 6, right? t1 equals t plus 6, and t2 just equals t, because that's the time that we're solving for. How much time does it take the second car to catch up with the first one? Okay, so on the x1 side, we have 1/2 of 3. That's acceleration was 3 meters per second squared, and then we have t plus 6 squared. On the t2 side, the x2 side, excuse me, we have 1/2 times 5t squared, because that's the t. Okay, well, I don't like those halves on there. You could FOIL that t plus 6, distribute the 3, and combine like terms and see if it factors, see what happens. Okay, but I have a more clever trick. Okay, I'm going to divide the 3 onto the other side, so you get 5/3 over there. T plus 6, still squared, equals 5/3 times t squared. And I'm going to take the square root of both sides. Okay, change colors for a new step. Okay, so I take the square root of t plus 6, and I get just t plus 6. Okay, now be careful. You took the square root of 5/3, it could be positive or negative 5/3, right? Because I could square the negative or I could square the positive and it equals the same. Okay, well, this is pretty nice. I've got my 6. I'm going to subtract t from both sides, a single t. So I just get 6 equals, and then I'm going to factor. So this is plus or minus square root of 5/3, and then minus 1t. So I'm going to factor my t's out, slow down and do more steps if it's not clear how that happened. It definitely is a minus there. Okay, so we've really got just one more step. Oop, and we're almost done. So I solve for t by dividing by this thing in parentheses. So I get 6, and then I get, I got plus or minus 5/3. But okay, if I had negative 5/3 minus 1, that's a negative number. Time can't be negative. Okay, the math equation doesn't know that these cars don't continue accelerating like backwards in time. And there was a time where like the second car should have overtaken the first, and it blew by, and then the first one came back and after waiting and caught up. Okay, so the math says at these rates that would also happen in the past. But time only moves forward, so we actually need only positive 5/3 minus 1. So we get a positive time, and it's got a lot of digits. we should round it to 20.6 seconds. Okay. See if you can set that up. If you really love the quadratic formula or other algebraic processes, they're logically the same, so you can try them and see what you get. But I'm very certain you should get 20.6. If you if you accidentally got like 26.6 or maybe 14.6, then I bet you misplaced your 6-second delay somewhere in the equation. Okay, thanks.